Let's modify this question. So on the test, thanks to our very own Oakley Smith. Let's do this. So we're going to say, during lunch, portion of our school field trip, Frances becomes curious as to what her 31 classmates are eating. Each student has a sandwich with the choice of white or whole, and we're going to say that they must choose. They cannot pass on anything, so they've got to take one or the other. White or whole wheat, chocolate or white milk, and we'll say melon or grapes. So it's going to look like this on the test. Okay, then they start giving you all this data, blah, 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 blah. Okay, this was the bread. A is the bread. This is white bread. And B is chocolate milk. And then set C is going to be the melon. So here we go. 18 of them have to live in this set A. So H plus D plus G plus E they got a sum to be 18. And so on and so forth. And it's usually the bottom where we're going to kind of start and work our way towards the top. So 3 of them had whole wheat, chocolate milk, and melon. Alright, so 3 of them had whole wheat, so that means they cannot live anywhere in the white bread. So they have to live in the chocolate milk and melon, and where chocolate milk and melon overlap, so this is chocolate milk and melon, so they overlap right here in F. So chocolate milk, melon, I gotta put 3 kids in there. So here we go. 3 kids live in region F. Okay, 6 of them had melon and white bread. So melon and white bread, where they overlap is anywhere in E or G. So we don't really know where to put them. We're just going to put them on the fence for now. So they live either in region E or region G, because that's where the intersection of white and melon is. So for now I'm just going to put them on the fence. So 6 kids live here. So maybe it could be like 4 in E and 2 in G, or 5 in E or 6 in G, or maybe 5 in E and 1 in G, or 6 in E and 0 in G. Okay, so we got that one done. 6 of them had chocolate milk and melon. Okay, so the intersection of chocolate milk and melon, set B and set C, they intersect right here. They intersect in region G and region F. So I know 6 of them have to live there, and I already have 3 of them in region F, so that must mean 3 of them live in region G. So there's my total of 6, and now I know if 3 live in G, 6 have to live between E and G, so that means 3 are going to live here in E. Okay, now the dominoes are starting to fall. So 7 of them had whole wheat bread and chocolate milk. So they cannot live in the white bread circle. So they have to live in the chocolate milk circle, and the chocolate milk circle is anywhere here. So I or F. So I or F have to sum to give me 7. And since I already have 3 in F, I know that I must be 4. There's got to be 4 kids in I. Okay, now 12 of them had melon, so my melon set already has 3, 4, 5, 6, 7, 8, 9. So 3 live in region J. 17 of them had chocolate milk. Alright, so chocolate milk is set B, so it already has 4, 5, 6, 7, 8, 9, 10. So that must mean I've got 7 living in D. Then 18 of them had white bread, so that's circle A, which already has 7, 8, 9, 10, 11, 12, 13. So I've got 5 kids here. Now, if I do 31, take away 5, take away 3, take away 3, 7, 3, 4, 3, that means out here in O, there are 3 kids. So these 3 kids must have chosen wheat, white milk, and grapes. So they do not live in any of these sets A, B, or C. So they had to have had grapes, wheat, and white milk. Okay, now let's do these two. So this is U, looks like a U, so we're going to call it union. And this is intersection. Okay, intersection is easier. So the intersection of A and B, that's where circle A and circle B overlap. So that's this region right here. So the intersection of A and B, you take all the kids that lived in region D, which were 7 of them, all the kids that live in G, which were 3 of them, and that is 10 kids. Okay, union B, that is all of set A and all of set B. So the wording is kind of tricky. So the union is OR, and the intersection is and that kind of makes sense. They have to live in set A and in set B at the same time, and the only kids that live in both sets at the same time would be the overlap, the intersection. Okay, the OR, union, so either they live in set A or they live in set B. Any of them qualify. So I got 5, 7, 3, 3, 4, 3. So A union B is either they live in A or they live in B, so you add them all up. It's 5 plus 7 plus 3 plus 3 plus 3 plus 4. And you cannot add the intersection twice, you only add them once. So add all those up, and there are 25 kids that live in A or B. Okay, how many kids, let's do this one right here. How many kids had wheat bread, chocolate milk, and no melon? Okay, let me fill this in real quick. So we had 5 in H, 7, 3, 3, 3, 4. Okay, so yours looks like this. So how many kids had wheat bread, chocolate milk, and no melon? Alright, so they did not have any melon, so they did not live anywhere in the melon circle. And they did not have white bread, so they do not live in this circle. They did have chocolate milk, so it has to be those 4 kids. So those 4 kids had chocolate milk, they must have taken grapes, and they must have taken the wheat bread. Okay, I'm gonna do some stuff. Let's do the next question. How many kids had white bread, white milk, and no melon? So they had white bread, so they live somewhere in set A. Okay, now they had white milk, so this is the chocolate milk circle, so they can't live in the chocolate milk circle. And they had no melon, so they cannot live in the melon circle, and that leaves us only with these 5 kids right here. So those 5 kids qualify. So the answer's gotta be 5 kids. Okay. The bottom one, how many kids had white milk in melon? So the white milk, if they had white milk, they cannot live in the chocolate milk circle. So none of these qualify. They had to have melons, so they must live somewhere in this circle. So the kids that live in that circle but that do not live in circle B are these three and these three. The kids that live in E and the kids that live in J. So 3 plus 3, 6 kids. Okay, now we got another Venn diagram. This one kind of is a little more straightforward. So Professor Dan is on a paleontology dig. They found 33 dinosaur skeletons. Some were intact, some were not, some were juveniles, some were not, and some were carnivores, and some were not. So here's what they found. Okay, A, this is my intact. B, this is the juvenile. And C, this is the carnivore. Okay, so this one's kind of different, so it's backwards. So the totals are given down here. I've got 11 total in set A. So H plus D plus G plus E's got to be 11. So it's kind of flip-flopped from the lunch. So if we start at the top here, 2 intact juvenile carnivores. So the intact, they have to live in the intact circle, and they have to live in the juvenile circle. So the only ones that live in both circles at the same time are the intersection, which is region D and region G. Okay, now there's 2 of them. Alright, now I don't know where to put them. Maybe there's 1 in each, or maybe there's 2 in D and 0 in G. I'm not sure, so I'm going to put them on the fence for now. So there are 2 intact juvenile carnivores. Okay, I think I read that wrong, because I didn't take into account the carnivore, so something kind of felt funny, and I think it's because I read it wrong. So let's try this again. Alright, so there are 2 intact juvenile carnivores. I was just thinking intact juvenile dinosaurs. So this is referencing each of the 3 sets. So 2 intact juvenile carnivores. So it's going to be the intersection of each of the 3 sets, and that is region G right here. So there's got to be 2 in there. So they are intact, they're juvenile, and they're carnivores. So 2 goes into region G. The next one, I got 5 intact carnivores. So now this is only referencing 2 of the sets. So intact and carnivores, here we go. Intact, they have to live in this circle right here. Set A. And let's see, carnivores, they have to live in this circle right here. So the only way they can live in both circles at the same time is if they live in the intersection. And the intersection is regions E and G. So these 2 are where it overlaps. And I know there has to be 5 that live in there, and I already have 2 living in there, so that must mean 3 live in region E. So that one's done. Okay, the next one. 4 intact juveniles. This is what I did at first. So if they are intact and juvenile, they have to live in D and G, and there's got to be a total of 4 of them, and I already know 2 live in G, so that must mean 2 live in D. Now there's a total of 16 carnivores. So 3 plus 2. I'm missing 2 regions, and I don't really know how to put the numbers there. So let's go to the intact ones first. This is going to make the dominoes fall. So there are 11 that were intact. So intact, I'm only missing H. So I got 3, 4, 5, 6, 7. So that must mean there are 4 in H. Now this might not make the dominoes fall. Alright, I'm missing something. Where am I missing something? Okay, I'm missing this guy right here. I never did the 7 juvenile carnivores. Okay, so 7 juvenile carnivores. So the juvenile set right here, the carnivore set, there has to be 7 in the intersection. I've already got 2 living in G, so that must mean I've got 5 in F. And now we can cross that off. So now 16 carnivores. I've already got 5, 6, 7, 8, 9, 10, so that must mean region J has 6 people living in there. 15 juveniles, 5, 6, 7, 8, 9. So that means I got 6 in region I. Okay, now, so the union. So the union is or. So either set C or set B. So anyone that lives in set C qualifies, or anyone that lives in set B qualifies. So the qualifiers are these 6 plus these 3 plus these 2 plus these 5 plus 2 plus 5 plus these 2 and these 6. So if we add that up, 8, 15, 16, 17, 18, we got 24. So 24 of them live in the union of C and B. So the intersection of A and C, man, I gotta erase these highlighters now. Okay, so the intersection of A and C, that is where the overlap happens between A and C, so it's right there, region E and region G, so add those up, 3 plus 2, so you got 5 kids that live there. Then, these 2 questions, how many non-carnivorous juveniles did they find? So they cannot be carnivorous. So that means they cannot live in set C. But they must be a juvenile, so they have to live in the juvenile set. So that leaves me with just these 2 regions, D and I. So 6 plus 2, so there's got to be 8 dinosaurs that were non-carnivorous, but they were juvenile. Okay, let's do the last question. How many carnivorous, so now they must have lived in the carnivorous, so somewhere in that circle C, but non-juveniles, so they could not be a juvenile. So they could not be anywhere in this circle. So that is these 3 and these 6. So 3 plus 6, we got 9 there. Okay, now come up with your own scenario for each of the 4 Venn diagrams. So scenario number 1, you have 2 sets that never intersect. They never cross paths. So we're going to go with kind of a theme for each of these, and we'll look at the freshman class here at Delta High. So I'll say set A is the freshmen, and I'll say set B are students in taking a concurrent enrollment class at Delta High. So kids that are enrolled in concurrent enrollment and kids that are freshmen at Delta High, these 2 worlds never intersect. There's no overlap ever. You got to be at least a junior to take concurrent enrollment. So scenario number 2, so A, I'm going to say again, is my freshman. And B, maybe could be an elective of art. So maybe there are some students that during their freshman year choose to do art. So there is an intersection, there's an overlap. Okay, now set 3. Let's do this. So the bigger set A, could be kids at Delta High who get fall break. And then living in that set is a unique set of students that are freshmen. Okay, then maybe for this last set, I'll say set B is the freshman class, and set A would be within that freshman class. There's going to be a unique group of students who make the girls' freshman basketball team. So girls' freshman basketball players are a small subset of the larger group of the freshman class. Okay, so let's look at this two-way table. At an international conference on global warming, 41 of the 93 attendees, okay, so there were 93 people total. So the 93 goes here. So this total plus this total has to be 93. And then if I do this total, so if I go this guy plus this guy and take its answer, and this column plus this column and take its answer, they must also equal 93. So 93 is the total. 41 were scientists. So now here's what I know. 41 of them were scientists. So that is 41. So of the scientists, there's like two subgroups. There's an American subgroup and there's a non-American subgroup. But I know the American scientists and the non-American scientists have to sum to 41. There were a total of 53 Americans, and that goes right here. So I can kind of maybe pause and fill in these blanks. If I do 93 minus 53, this is 40. So I know that the non-Americans at this conference, 53 were American, 40 were non-American. And if I do 93 minus 41, I know that there must have been 52 people that were non-scientists. Okay, now I'm going to plug this number in. So there were a total of 53 Americans. 23 of them were scientists. So I know that one. So I can fill this one in, because I know they have to add to be 41. So I'm just going to go 41 minus 23. That's got to be 18. And I could go horizontally. 23 were American, and I know there were 53 there that were American. So 23 of them were scientists, and 30 of them were non-scientists. I know there were a total of 40 people non-Americans, 18 were scientists. So if I go 40 minus 18, that gives me 22. And it should work both ways. 30 plus 22 is 52. 23 and 18 is 41. 23 and 30 is 53. 18 and 22 is 40. And both sum to 93. So that works out. Okay, now, the conditional deductive argument. So the deductive versus inductive. So let's do a bunch of deductive. So kind of conditionals and if-then. So we're going to complete the arguments based on the instruction and the opening premise. So you're given one premise, and we're going to use this same premise for the entire run here. So determine if they're valid by drawing a Venn diagram. If they are valid, determine if they are sound. So if the premises are legit, you got a good sound argument if it's valid. So here we go. So your first premise is if you like candy, then you'll love Halloween. So this is important to understand. This first part, we're going to call this the hypothesis. So if you like candy, then you'll love Halloween, and that is kind of an outcome based on the first idea. You'll love Halloween. We're going to call this the conclusion. Okay, now we're going to use the same opening premise for each of the next 4 questions. So to draw a Venn diagram, the conclusion is going to be the larger set. So there is a set here. Everyone who lives in this world loves Halloween. And your conclusion is always going to be the larger set. The subset, there's going to be a group of people in this world who love Halloween, but something unique to them is they are going to like candy. So if you live in this candy world, you also live in a larger world where you love Halloween. So that's your Venn diagram. Your conclusion is always the larger set, and your hypothesis is the smaller subset. Alright, here we go. Number 1, we are instructed to deny the hypothesis. So my hypothesis is if I like candy. So the first premise, if I like candy, then I love Halloween. My second premise needs to deny the hypothesis, so it's going to be this: I don't like candy. So my conclusion, I can deduce that if my first premise is true and my second premise is true, my conclusion is going to be I won't love Halloween. I won't love Halloween. Okay, now let's plot it. You need to plot the second premise. I am a person who does not like candy. Now here's the problem. If I do not like candy, I cannot live in this subset. I can live here, or I can live here. But I cannot live in the subset. So because I'm not really sure where to plot myself, I don't know if I'm in this world or if I'm out of this world, that logic is not valid. The only way for it to be valid is if you know exactly where to plot yourself. And because I got 2 choices, I don't know where to put myself, so it is not valid. So that's a bad argument. Their logic was pretty weak. So there's only 2 instances where it's going to be valid, and that is if we affirm the hypothesis or if we deny the conclusion. So number 2, this one's going to be valid. So let's look. So the same opening premise. Premise number 2, I need to deny the conclusion. So the conclusion is this: I love Halloween. If I deny the conclusion, that means I don't love Halloween. So based on my first premise and my second premise, I can conclude if I don't love Halloween, I don't like candy. Okay, now plot me according to the second premise. So my first premise sets up this world, sets up this Venn diagram. My second premise, I am a person who does not like Halloween. So I absolutely cannot live in there because they live in the love Halloween. I cannot live in there because they love Halloween. I must live out there. That is my only choice. And because that is my only choice and I know exactly where to put myself, the logic is good. That is a valid argument. Now the question is it sound? Are my premises legit? And probably not. This first premise, just because you like candy does not mean, it's not a guarantee that you're going to love Halloween. So the logic is good. Don't worry about the premises. You just follow the logic. That is a very logical scenario. But it is not sound because this first premise is questionable. That's not true for every person on earth. So that is not a sound argument. Okay, number 3. So let's do the same thing. I've got a big world here that loves Halloween. And in that world, I have a smaller subset that loves candy. Okay, number 3. You need to affirm the conclusion. So the first part, always the first part is the hypothesis. And as a result of that hypothesis, this is the outcome. That's the conclusion. So you need to affirm the conclusion. So let's say the conclusion is true. So I love Halloween is going to be my second premise. I love Halloween. So the conclusion, based on your first premise, if you love Halloween, then you can maybe conclude, you can deduce that I like candy. So here we go. The first premise sets up this world that we've got. The second premise, I need to plot myself in that world. So I am a person that loves Halloween. Okay, here's the problem. I could live there. I could live there. I have to live somewhere in this circle, but I don't know. I got 2 options. I either live in the candy world or I don't. Because I don't know where to plot myself, the logic is screwed up. This is not valid. And the last one, affirm the hypothesis. The first part's the hypothesis, second part's conclusion. I like candy. Affirm the hypothesis, so I am a person, I like candy. So I can conclude based off the first 2 premises that I am going to love Halloween. So I need to plot myself according to the second premise. I like candy. I go exactly, that's the only place I can go. And because I was directed to only one unique spot, the logic is excellent. Logic is valid. So same thing as before. The argument is probably not sound because that first premise is subjective. Who knows? So the logic is good, but it's not very sound, not very convincing. Okay, last one. So we got 4 more scenarios. Categorize these arguments. State whether they are valid by drawing. Okay, same thing. So here we go. Both premises and conclusion are given. So if it is a bird, that is my hypothesis. Then the conclusion is the young hatch from egg. So the conclusion, this is the big circle, egg. And in that subset, I have a species that are birds. Okay, premise 2 is where I live. I'm a bird. So I live right here. If I live right there, that's only one place. It must be valid. So let's categorize the arguments. Here's what they did. They affirmed the hypothesis. So condors are a bird. So they're talking about the hypothesis. And I am a bird, so that is affirming the hypothesis. And that is always going to be valid. The other one is if you deny the conclusion, that will always be valid. Now here's the question. Is that a sound argument, or are the premises weak? So the first premise, if it's a bird, the young hatch from eggs. So the only thing that would bring that into question is if there is any species of bird on Earth that does not hatch from an egg. And I don't know, you'd have to Google it. But to me, that's probably sound. I think probably all birds hatch from an egg. I'd maybe bet on that, but I don't know. You'd have to Google it to be sure. You'd have to find, if you even found just one species on Earth that did not hatch from a bird, then it wouldn't be, you could prove it wrong. Okay, so B, this is the hypothesis, this is the conclusion. So the conclusion is the big set here. So this is computers. And in that computer set lives a subset of moon. So here we go. We can build a computer. So they're talking about the conclusion, and they're saying the conclusion is true. So they are affirming the conclusion. So therefore we can deduce that we can put a man on the moon. So if we can build a computer, I don't know where my computer, I don't know where to put myself. I put myself there, I put myself there. I got two options, and because I don't know which of the two options to go with, it is invalid. Okay, C, if the figure, so if this is the hypothesis, then it has four sides, that is the conclusion. Alright, so the conclusion is the bigger set. So four sides. If a figure is a quadrilateral, so that is a smaller subset. Okay, so you turn your brain off. You don't even try to understand these premises. We're just strictly doing from a logic perspective. So we're not trying to think about them, we're not studying them out. We're just following the logic, see how the logic flows. Then maybe at the very end, if it was valid, then start to think about the premises and if they are reasonable, convincing, factual, something that you buy into. So don't even think about anything that's going on. Let's just go totally abstract and just plot them. So the first side is hypothesis, second one's conclusion. Conclusion is the big circle. Now premise 2, this is going to be kind of where I live. I am not a quadrilateral, so I cannot live in this red set. I could live in here, or I could live outside both of them altogether. So I don't know, I've got one of two choices, so this is not valid. And what they did, they talked about quadrilaterals, which were the hypothesis, and they denied it. So they denied the hypothesis, and that is never going to produce a valid argument. Last one. If you get at least a C in your math class, you may drive my car. So this is the hypothesis, this is the conclusion. So my conclusion is a world where you can drive my car. In that world there is a subset of people who got a C in math. Okay, now premise number 2. You are not driving my car, so you do not live in this world. You live here. So that is valid. So what they did, so they focused on driving the car, which is the conclusion, and they denied it. So they denied the conclusion, and that will always result in a valid argument. Okay, now that we know it's valid, let's go back and let's test the premises and let's see if they are sound. So if you get at least a C in your math class, you may drive my car. So that looks like it's just some deal some teacher made with his students. So probably sound. We'll suppose he's telling the truth. So that is a sound argument based on the deal that was made between that teacher and his students. Okay, that is it.